Start again. So, good morning, students. Here, myself, Dr. Vishwik Mandal, and today I am giving the lecture on renewable energy technology. This is the subject we are teaching in the chemical engineering branch. It's for fifth semester. So, today, actually, I will cover one of the very most important energy sources, that is hydrogen, and in particular biohydrogen. This is a chapter and a topic in the renewable energy technology. So, guys, before starting or going to the main topic, I would like to say about the renewable energy, the need of the renewable energy. And most of you know about the necessity of the renewable energy. So, guys, as an engineering student or an engineering member of an engineering community, we always believe that progress is always possible. There are never we say about that this is the final one. So everywhere, progress is possible. Everyone we know that any technology, whatever it is 10 years back, what is the upgradation and the present status is not at all the final. So there are the scope for its improvement. That's why this is very important to believe that progress is always possible. Successfully dealing, you can see these slides. I have write that point. That successfully dealing with change in today's volatile and complex global business landscape is more important than ever. While the coronavirus pandemic gives us many lessons, and again it reshuffled the global priorities. We cannot put off our efforts to fight the climate crisis and exploration of abundant renewable energy sources. So every company need to spend some percentage of their money for exploring the new and renewable energy sources. And obviously, we have to find out what are the change making sector trends. So, business and researchers are constantly faced with the new challenges. As you can see, just many years back, people used the solid fuel like coal. Then the energy consumption pattern or the global practices shift from the coal to the liquid fuel, and liquid fuel to gaseous fuel, then gaseous fuel to the next generation hydrogen fuel or what else. So it change, the pattern is changing. So this is obviously that some compulsions are there. So the trend said, everywhere now we are the global scientists, everywhere people are searching for the hydrogen energy and the new kind of energy. So this is the green, absolutely environmentally benign energy sources. The hydrogen, why we should go for the hydrogen? Because you just see the trend, coal to liquid fuel to gaseous fuel to what next? If you see, this pattern is shifting based on the hydrogen by carbon ratio. If you see the composition of the energy sources, like in the coal, in the liquid fuel, the hydrogen by carbon ratio, what is happening? Gradually increasing. And all you know that the hydrogen energy source, the energy source actually, whatever, whether it is solid, liquid, gaseous, is fossil fuels. So it's mainly composed of hydrocarbons, and we extract the energy while we burn it, right? So when we burn this hydrocarbon, so it actually yields water and carbon dioxide. If we consider the complete combustion, so now hydrogen by carbon ratio gradually increasing. What is the trend? If we decrease the chain length of the hydrocarbon, so hydrogen by carbon ratio will increase. For example, for methane it is 4, for ethane it is 3. So gradually increase the chain length, so will reduce. So in the same way, in the coal, the long chain hydrocarbons are there. Then liquid fuel it is shorter. Then gaseous fuel again it is shorter. So what next? Next is the hydrogen, which is not at all chemically bonded with carbon. If we burn and also burn the hydrogen, it will only yield water. So there are no emission of carbon dioxide. So that is the beauty of the hydrogen sources. And what else? As a fuel, it should have some properties. Like it has the highest energy content per unit weight of any known fuel. So it is 143 gigajoule per ton. Just imagine it has the highest content. So uh, you know as a energy sources or as an energy carrier. So it is the best option for. But for that we have to make the infrastructure. We have to ensure the reliable hydrogen production methods, the machineries. We have to explore or design the reliable appliances where hydrogen can be used. We have to design and test the safe storage of hydrogen. Then hydrogen can be available everywhere. We can replace the present infrastructure with the hydrogen economy or roadmap. Here, guys, few process you can see because progress is always possible. So we will not think about the single process. So the possible options, the different process for the production of hydrogen, it can be produced, from fossil fuels like coal, oil, natural gas. By cracking, reforming, we can generate hydrogen. In the refinery, you go for the reforming process. Actually, we are upgrading the quality of the gasoline by improving its octane rating. But byproduct, we are getting the pure hydrogen. So, steam reforming, all that. And other part is that very ancient process like electrolysis, splitting water, it will generate, it will give hydrogen and oxygen. But for that, it need electricity. So that electricity, if we supply from the renewable energy sources, renewable sources means that source can be renewed within the defined time. So here direct solar energy we can utilize, and solar photovoltaic we can utilize for supplying electricity to the electrolyzer. Wind energy, geothermal. So that would be the absolutely green hydrogen will produce. And again, apart from this, direct solar energy can be utilized using some semiconductor particles, put it into the water, and then exposed to the solar insolation directly, so that it can produce, hydrogen and oxygen. Apart from this, there are many bioprocesses, biological process. From biomass, we can generate biomass. There are many type of biomasses are there, but specifically, biodegradable material, biomass, that can be generated hydrogen by gasification. Some biomass with the help of microorganisms through fermentations, we also can produce the hydrogen, and that can be done by the biohydrogen. That is absolutely great because there are, no such harmful emission to the environment. So I am actually giving the focus on this particular hydrogen because it has huge potential. Like in compare that biogas or like methane gas, gobar gas plant. how the people generate and it becomes so popular that household are using commercially also we can utilize. We are utilizing without any hassle. So like that, if we use some specific bacteria that ferment this material, biodegradable material, can generate hydrogen, and that would be a very nice technology. That can be spread like a standalone system for household generations. The other part. Only issues remain in our mind is that the whether hydrogen is safe to use. Yeah, it is safer. It is lighter and safer because it is somewhere if it leakages are there, so it will go upwards very fast. It will not wait to explode. So that is a different issue need to be discussed. But comparatively, it is safer in terms of the suffocation, in terms of the carbon emission, in terms of the vapor cloud explosions. That's all. So this is revitalizing rural economy. This is also one part, you know, that revitalizing rural economy. If we are talking about this biohydrogen, advancing domestic resources for a thriving bioeconomy, because we will produce the biomass that will be degraded into the hydrogen, and that biomass can be produced economically by even rurally we can generate it. So just imagine the farmers or the people having the business for production of biomass that will give us hydrogen for the other uses. Biofuels include cellulosic ethanol, biodiesel, and renewable hydrocarbon dropping fuels. I hope you understand these points. So, guys, we're talking about biohydrogen and hydrogen produced through the action of living organisms. It's called biohydrogen. So, remember this definition. Biohydrogen is not a new kind of hydrogen, it's green hydrogen. It's produced with the help of living organisms, microorganisms. That's why this nomenclature. How we get the biohydrogen? There are various processes again. Biohydrogen means some algae also can be utilized that can produce clean water and produce hydrogen. That also can be turned by the water. So there are various processes. We make a list of that, such as biophotolysis of water using even the algae, blue algae, dark anaerobic fermentation and photofermentation, and microwave water gas shift reaction. So among all these options, very interesting part is the anaerobic fermentation and photofermentation. So fermentation can be utilized and specific bacteria are there. For example, Enterobacter cloacae, Rhodobacter sphaeroides for photofermentations. And these fermentations, even dark fermentation, dark anaerobic fermentation, I think dark means it's independent of light. Do not depend on light. So fermentative hydrogen is having major advantages of fermentative hydrogen production process are higher evolution rate of hydrogen and a wide gamut of substrate utilization. So just imagine this many number of biomass. It's a mixture of biomass can be utilized with a bacteria. I'm talking about that Enterobacter cloacae, even just E. cloacae. So that can produce. So with a flexible operating conditions like the temperature ranges of that, even we can improve the activity of the bacteria itself by mutations. By mutating this Enterobacter cloacae, that can even be further efficient. And higher evolution rate means theoretically it can evolve 4 mole per mole of glucose, 4 mole of hydrogen it can generate. And having the higher, if we apply the proper strategy like reduction of pressure, it can generate higher rate of hydrogen. maximum yield of fermentative hydrogen production. So far, the literature is there. You can see among all these fermentative hydrogen production process, E-clocky, that is interrupted clocky yield the maximum yield. It is 3.8 mole parts. It is reported under reduced pressure. I also work on this. We have developed 1,000-liter pilot plant during the research of this fermentative biohydrogen production in IIT Kharagpur, Indian Institute of Technology, Kharagpur, and we found that among 4 mole of this hydrogen, we achieve 3.9 mole of hydrogen at reduced pressure. So it's close to the theoretical amount, and it's till now it is reported. Based on this data, based on this data, we have also designed 1,000-liter pilot plants, and it's now almost commercialized process. Engineering approach in the eye of last principle that I'm talking about, that by changing the pressure, this process yield changes. Probably it's a new dimension we have explored. By changing the pressure, the bioprocess changes its efficiency. And it was probably not reported before. And it's not only theoretical study or laboratory studies, these also implemented, and some companies also accepted this technology and installed the plant. So decrease, just see the theory. The decrease of hydrogen partial pressure could consider as an approach towards improvement of hydrogen productivity. So these lessons can help you to do research project, and obviously further improvement scope of improvements are there, and you can reach a new height for this. So in general, biological hydrogen production from organic substrate is limited by the thermodynamics of the hydrogenous reaction, involving the enzyme catalyzed transfer of electrons from an intracellular electron carrier molecules of protons. So this is the mechanism that enzymes are there, and even the activity of that enzyme also can be enhanced by iron hydrogenase. I'm not going to the details of that in this lecture. So here the comparative study, you can see that we already explained that. You see this one 3.9, it is achieved using interrupted clocky DM11 double mutant. So as I already told about that, mutation of the hydrogen producing bacteria also can improve its activity, immunity towards the other toxic environment. So, and also it responds to the last atelier principles, like if we reduce the partial pressure of hydrogen by reducing overall pressure, it was observed that there are a lot of explanations are there, that it can improve the dissolutions of the hydrogen from the solutions, such that it improves the contact area between the cell membranes and the substrate by detaching the gas bubbles formed on the cell wall, like these are the mechanisms. Now see the setup, experimental setup or laboratory setup you can do, replicate for your future projects, that could be helpful for the future generation. So though it was this process already is patented, so you can check it. Yeah, this is the 1,000-liter biohydrogen plant through which fermentation we are generating. It's not theory only; it's practically implemented. So they should not have any doubt on it. Microorganism use, as already explained, DM11 is double mutants, and obviously there are few conditions need to be maintained, because cells should not rupture by huge stirring. So stirring RPM should be limited or restricted, and the proper environment we have to give for the living organisms, because living organisms also behaving like human beings, like proper environment should be given, proper pH, proper nutrients, and proper temperature to maximize its production rate. Process parameter for hydrogen production. So this is the research part I'm giving you to explore your mind for the, so that you can carry out this, because this is the futuristic fuel. The world is searching for it, and it will be a very good job for us to be part of that. If we contribute some part for the hydrogen production technologies or strategies, so obviously future will name the people that those contribute for this. So here the parameters, conclusion or conclusions, already we made. Though there are two types of conclusions are there in every aspect or every possibilities, optimistic and pessimistic conclusions. So here I'm giving you the optimistic conclusions. Is that among various approaches to decrease the hydrogen partial pressure, so by changing the partial pressure, it is possible to improve the hydrogen evolution rate or production rate. Though some people believe that bioprocess could not become controlled from outside parameters instead of temperature and the nutrients, vitamins, but it is proved as wrong, because by changing the pressure it is possible. Higher production rate, high yield, and lower initiation rate of hydrogen productions are thereby achieved by the exponential minimum energy. Because the drawbacks of the bioprocess, are mostly addressed, and it was shown that it is possible to change or improve that process, their parameters. Okay, so thank you guys. I hope as a renewable energy sources, we will give a big space for the biohydrogen. Hydrogen already occupying this space, and the production strategy of the hydrogen, one of the major parts are there is the biohydrogen. Okay, so thank you.